to your priority snowplow routes. So then after that entire process, that's the analysis. That's the entire statistics, that's the entire autocorrelation, that's it. That's just that small section there at the end. That's that final section. That's where the regression analysis, the autocorrelation test comes in. And finally, the results are kind of summed up in this really nice little map that you also can make in ArcGIS Pro. So this is a map of the density of first priority snowplow routes by census tract. So this large map shows, again, that distribution of routes calculated. It's calculated by the percentage of total roads in each census tract that are classified as priority 1 snowplow routes. So that's where that calculated the proximity to each priority 1 snowplow route comes in. So as you can kind of see, the highest density of priority 1 routes, as indicated by those navy blue lines, is clustered in the central part of Duluth, right next to the lake, which is also the economic center of the city. You can also see it kind of here in this inset. You have all of these nice grid lines as well, because these are all city blocks. All of those roads are being plowed, first and foremost. So then kind of your density tapers off as you travel further from the city center, with the least amount of priority routes being located in the south. So that's between 9 and 24% of the roads in this area are classified as priority 1 snowplow routes. So to analyze the effect of those selected demographic variables on the distribution of those snowplow routes, I ran a spatial lag regression model. So the distribution of the 3 most important variables to that model are shown in the maps that I'm going to pull up. So this first map is the distribution of population density, which follows a very similar pattern to the snowplow map, with the highest population density near the city center and less people living towards the edges, which kind of makes logical sense. So the second map shows the pattern of median household income, which kind of seems like an inversion of the previous map, with more wealthier people living on the outskirts of the city. That orange is a higher median household income. And then finally, this final map shows where the highest percentage of residents that are reliant on public transit live, which again, they live near that city center, which again makes sense given that the densest population is also in that area. So then for those of you who are very statistics-focused people, here's the results of that regression model that I ran. So this table shows these 3 variables that I mapped previously, as well as a 4th, which is percent foreign-born, which comes from that 2014 paper from Jeremy Levine. So here you can see kind of what the significance of it to the model is. And then really what I want to focus on is the adjusted R-squared value of 0.352. Indicates kind of a moderate fit for the spatial lag model. In social sciences, you tend to have a lower R-squared value than natural sciences. This spatial lag model was chosen over the OLS model and the spatial error model because it has a lower IKK information coefficient criterion value, so which indicates information lost. You want the model with the lowest amount of information lost. This was it. It also has a low global Morantz I index, which indicates low levels of spatial or autocorrelation, and it also indicates that the demographic values that I selected are reliable. And then a low variance inflation factor, typically you want it to be under 2.5, also confirm variable reliability via an absence of multicollinearity. So then finally, so what can we conclude from those maps and this regression analysis? Firstly, that population density and public transit commuter percentage are positively associated with priority snowplow routes. And then median household income has a negative relationship to the density of priority snowplow routes as well. Surprisingly, the percentage of foreign-born residents had really no significant association with the snowplow routes, which counters the conclusion made by Levine, which is popping up here.
Sorry.
That's okay. I'm gonna keep talking. Which counters the conclusion made by Jeremy Levine in 2014 that foreign-born residents are less likely to receive municipal services. So then the relationship between variables means that the highest density of priority 1 snowplow routes are located in poor, more densely populated areas of Duluth, where the residents are more reliant on public transit, which indicates that it indicates an absence of social justice issues related to the density of those snowplow services, which is great news. In case of emergencies, you're not prioritizing your white folks when you're getting people out of 20 inches of snow. So, to conclude a little bit, so there were a lot of things that perhaps could have gone better, or improvements that I can make for the future for this, because this was, just done in a couple of weeks. So there were definitely some challenges and limitations for this project. So I was limited in my preliminary research because there is just a lack of information and research available about the logistical, societal, and health implications of snowplow routing, especially when it comes to snow emergencies. Most research is about the mechanics of actual snowplow vehicles, like what plows can be attached to the front of this to shovel more snow. So it's really talking about technology and not logistical implications. This project was also a challenge for my GIS skills. This is something that I am pursuing a degree in, and this is the purpose of the training. So there are very few city data portals that actually have snowplow data. Duluth was one I was able to find first, and I actually just recently learned last week that the city of Champaign has some snowplow data. It's in a different format, so the same analysis might not be possible. Also, formatting the data for analysis was a task, trying to figure out how to generate line points upon those lines and then figure out what runtime it needed. It was an ordeal. There were a lot of late nights spent in the computer lab. But however, this project has a lot of potential so I could find a stronger regression model. I could experiment with different demographic variables to see if other patterns emerge. I can also expand the studies to other cities in the Midwestern Canada that have similar climates, places like Champaign. It has the data, but we receive a lot less snowfall than Duluth. Or Montreal, Canada, for example, receives a large amount of snow, but I am not sure if they have the snowplow data. So finally, these are a few of my references that I used to kind of guide my research, as well as a tutorial on how to run a similar regression in ArcGIS Pro that is free and open source. And thank you so much for having me today. Do you have any questions?
Alright, really quickly, if you have any questions, there are microphones on each of the tables, so if you just push and talk, you can have a question, but raise your hand first and we'll call it.
Go ahead.
Can you hear me? Oh, yeah.
Yes.
All right. This is a really great talk. I feel like I learned so much about snowplows, which is something I hadn't really thought about despite growing up in New England. So thank you for really enlightening me on this. For your data source, I know sometimes there's data that can talk about the zoning of that particular zip code or tract. Like, is it primarily residential or primarily for commercial business? And so I was wondering if that variable entered into your analysis at all, of looking at, was commercial zoned areas a priority in addition to population density?
No, not in this particular analysis. I did find from analyzing just population density that it tends to, I'm assuming that the population density in the city center is also, it's probably multi-zoned, so you probably have businesses on the first floor and residential on the second floor. I'm not a resident of Duluth, so I probably don't have that firsthand experience. But again, that's something I could bring into the future to see if the city is prioritizing economic routes or if it's prioritizing residential routes. Because I think there would be, because if they're prioritizing economic routes, if they're prioritizing the grocery store over the nail salon, that would be, there might be another issue there. What is the city prioritizing? But I think that would be a really interesting variable to bring into the next one. Because I think I initially tried to not do it at the tract level, but the parcel level. So and that was a very large amount of data that took a very long time to process. So we kind of scaled it up a little bit for the sake of time and efficiency.
Yeah. Or routes to healthcare, hospitals and stuff for emergencies.
Absolutely, and I think that probably plays into the plowing of the main roads versus the secondary roads. So yeah, that would also be a really interesting thing to plot your healthcare places and then figure out figure out the quickest route to there, and is that part of the priority zone route? Yeah.
Have you thought about agendas look at snowplow? And maybe this is a resource that's going to be valuable because I figured there's probably not a lot of snowplowing data out there, but there's this book called Invisible Woman, Exposing Data Bias in a World Designed for Men. And I remember this whole section being about snowplowing and looking at a gendered way about that and how that tied into primary roads, secondary roads, public links and references to a whole bunch of other snow resources.
Absolutely. I think that's a really good resource. I'm gonna come back to you later to get the name of that book. Yeah.
I gotta get the name.
Yes, I'm gonna come back to you later. I'll
Okay.
meet you after the talk, and I'm gonna get the name of that book because I think that sounds really interesting. Because a lot of design things, like seatbelts, are designed for men. They don't have like female test dummies. So again, just not in just product design, but also in infrastructure design. I
Yeah.
think that's a really interesting angle to put on it. Yeah. Anything else? Yeah.
Yeah, I have a couple of questions about the data. First, we had a measure there for cancer tumors. It's called those cancer tumors. I want to find out what
That was from the Census Bureau and the American Community Survey data. That was measured, I think it was just the percentage of people in a tract who commute to work by public transit. So in the entirety of, yeah, go ahead.
So it's self-reported.
Yes, it is unfortunately, yeah, the American Community Survey is all self-reported. So that's, I kind of had to put the phrasing identifies as white because, again, these are real people responding to this and it's what they feel about themselves. So again, there's a lot of data for like, do you self-report as mixed race? Do you self-report as white? Do you self-report as somebody who drives to work more often than not? So it's really these, not binary categories, but you have to pick one. But yeah, that's a good question.
But yeah, I wasn't aware of that.
Yeah, there's a lot of stuff in there. I got one in the mail last year and I was like, oh, the amount of stuff that is in here is very detailed. I felt like I was, writing it down.
The other question I have, yeah, I really like this study because it's not popular. And I like the other. I noticed in the model that it is about correct. Wondering what other, like you mentioned, very open on I wonder if it's graphic density, economic conversations on and like
Yeah, absolutely. And I think that goes back to a previous question about zoning. So where the economic zones are, where the residential zones. I think that I picked the variables I did because, so like population density makes sense. I think you want to plow where there are the most people, so you get the most people out the fastest. I wanted to see if the household income was related to it. I wanted to see if they were prioritizing like economic status, like rich people versus poor people. Percent foreign-born was kind of a wild card because again, I could not find, there's so little literature on snowplow routing and emergency management. Maybe emergency management in general, but specifically snowplow routing. So that came from a paper I think Jeremy looking at, a sociologist. So I was looking at percent foreign-born just as, is this a factor in how Duluth prioritizes their snowplow routes? So I think there are definitely other variables that can be considered, and I think there are probably variables that garner a better fit. But again, I think that would be a really good future study if I, again, expand this a bit more. Yeah. And then, yeah, I think go back to the slide real quick.
Which one?
Just the final one.
Oh, this one?
Yeah.
Oh, I didn't change the. Sorry.
It's okay.
Sorry about that.
That's okay.
I didn't double click.
Basically, it was going to be yeah, if you have further questions, you can I have my email there. I also have a QR code to my LinkedIn. You can reach out through that. But yeah, I really appreciated y'all having me, and I appreciate you having me today. Thank you so much.
All right, and now to introduce our second speaker for session A, it's going to be Sierra Raglin, postdoc at the University of Illinois Urbana-Champaign, with metals and microbes, assessing the influence of urban land use on metal-microbe interactions through Chicago, Illinois.
Okay. No. Is there a way to go forward and back,
Just,
or
I think just forward.
just forward?
But
Okay.
if you need to go back, just kind of signal to me like
Okay.
something.
Oops, I don't know if this is on, but I have a kind of loud voice. Okay, that's fine. Hi everybody, thank you for having me. All I have to say is I'm really not ready for winter yet, so that last photo was like, no. So thank you for having me. I'm super excited to be here. I'm a postdoctoral research fellow at the University of Illinois' Urbana-Champaign within the Institute for Genomic Biology. And IGB is a team science research institute, so I'm on the infection genomics for One Health research team. So I'm gonna skip that. And so I'm gonna jump right in. Broadly, I study microbiomes in environmental contexts, and my interest in microbiomes is kind of how are humans inadvertently altering environmental microbiomes in ways that can negatively feedback onto environmental and human and animal health. And so microbiomes are a really core concept, core component of the concept of One Health. And so essentially One Health is kind of acknowledging the interaction between human, environmental, and animal health. And so obviously microbes are really important for global redox cycling of nutrients, carbon, nitrogen, phosphorus. They're really important for the evolution of ecosystems through primary succession and kind of terraforming ecosystems for the improvement of multicellular organisms. And certain microbiota are really important for colonization of different host environments. So your gut microbiome, your oral microbiome, and the same goes for plants and ruminants and pets and whatnot. And so they're everywhere, and that's why I'm really interested in them. But I specifically study soil microbiomes, which are often, in my opinion, neglected in other systems beyond just agricultural systems. And soil microbiomes are really unique because they can harbor 10 to the 9th bacterial cells per gram of soil, which is kind of equivalent to around 50,000 bacterial species, where in comparison the human gut microbiome might be only around 3,000 species. So it's a hyper diverse ecosystem. What this says in the bottom is that because of the complexity of soil physiochemistry, you get this incredible diversity of microhabitats for microorganisms to exist in that have these chemical and physical gradients. You can see like the red versus the blue. Some of the gradients are related to oxygen or water or pH, and it leads to the evolution of this incredible metabolic diversity of microbes in soil. So some microbes might end up being kind of like these green guys over here and be what we call specialists, and they can only occupy very specific spaces in soil. And then some are these generalists where they have the flexibility to occupy different niche spaces in soil. Another key features of microbiomes is really what's really interesting, and it's actually one of the major One Health implications of microbiomes, is that they have this incredible capacity to exchange genetic material. So we get all our genetic material vertically, from parents once, and microbes also can essentially clone through a process called binary fission, but it's kind of blocked out by the camera. But they also have the capacity for horizontal gene transfer, where they actually take these small elements called mobile genetic elements, and they can trade them in the microbiome like Pokemon cards with other microbes that they're not even related to. And so that allows them to rapidly adapt to stress. And so when you think of things like antibiotic resistance, and it's becoming a larger and larger issue, and it's because they're able to rapidly exchange these mobile genetic elements between microbes that they're not even related to in these complex communities, whether it's the human gut or in soil. And so this issue arises of microbiomes adapting to stress in soils specifically because of the physiochemical structure of soil. Certain toxic elements like metals can actually accumulate in soils, and they generally have very low mobility. And so this really relates to the surface area of soil. So this was a really great paper that came out this year. And you can see where humic acids is a type of organic matter in soil. And so the surface area will increase as more organic matter occurs in soil. And the surface area is going to impact how well toxic metal elements can actually absorb to soil. And so Illinois has uniquely high organic matter soils. They're called mollisols. They're defined by the USDA by having high humic acids contents, and that's why we're this incredible center for ag, because organic matter is really important for soil structure. It's really important for water infiltration, water holding capacity, nutrient content. but when neglected, they can also have these metal elements accumulate, and they generally have low mobility, so they're not always leaching out with the water the same way like nitrogen and other nutrients can. And what you can't see here is like ultimately the mobility of certain metal elements depends on the chemistry of that metal, with lead being very immobile in soil, and so it varies. I think it was like lead and then copper and zinc and nickel vary in their absorption to soil. And so metal deposition varies by land use. There are natural sources to a lot of these toxic metal elements, like volcanic eruptions and erosion of parent rock material, but most of the other sources are coming from something humans are doing in some way, whether it's agricultural application, or it's actually atmospheric deposition, or it's these industrial sources, or wastewater discharge and whatnot, and fires. And so metal deposition ends up being heavily influenced by human land use history. And ultimately, this matters for soil microbiome specifically. This is the most biology heavy slide. So essentially, antibiotic resistance is arising in clinical settings from the use of antibiotics, but we're also learning that antibiotic resistance can evolve as microbes are evolving to other and adapting to other toxic elements like metals. And so what we call a resistome is the genetic potential of a microbiome to have antibiotic resistance genes. And so you can look at the diversity of antibiotic resistance genes or the overall abundance of them within a microbiome. And so research has shown that there's these three main mechanisms at which microbes can acquire antibiotic resistance because of metal resistance genes. And so some of them, and one of the most alarming one is this co-resistance mechanism in the middle, because the antibiotic resistant genes and the metal resistance genes can actually be physically linked on mobile genetic elements. So if a microbe is adapting and exchanging these metal resistance genes, they could also be bringing along antibiotic resistance genes with them. And so some of them will give them pumps that can pump toxins out of the cell, whether it's an antibiotic or a metal. And then some metals can actually just change the expression and the regulation of antibiotic resistance genes. And so this is a problem because now there's antibiotic resistance in a lot of other places that we didn't know that it was going to be. A lot of the research assumes it's happening in hospitals, but it's actually happening in the environment. And so ultimately, the project that I'm working with in collaboration with Marina Kolak, as well as crop science professor Dr. Andrew Marganon, is to really understand how urban land use drives microbiome adaptation to heavy metals deposition. And so the overall project hypothesis is that heterogeneous deposition of toxic metals due to variation in urban land use history drives spatially distinct patterns in metal-directed antibiotic resistance gene diversity within urban soil microbiomes. And so ultimately I'm taking this multi-scale One Health approach for this project, and so I'm going to incorporate social determinants of health to characterize urban land use with point-based heavy metal analyses, as well as microbiome metagenomic sequencing from all of those same soils. And then I'm going to be doing a lot of bioinformatics to align those sequences and identify which resistance genes are there, and kind of do this kind of multi-scale, multivariate analyses. And so I'm leveraging a data set that was already collected, thank the gods, because that means I didn't have to do the field work. Shout out to Dr. Andrew Marganon. Oh, you can't see the QR code, but he and his master's student, George Watson, did this massive grid sampling throughout Chicago. And they originally mapped these soils for lead, copper, zinc, phosphorus, and pH. And it was originally 941 samples, and nobody is paying for that sequencing. So I had to reduce the number of samples to something that was actually financially plausible for a microbiome data set. So I used, with Marina's help, used the JODA app, and did a kind of geospatially formed k-means clustered it into these 30 major clusters, and then subsampled each, so then I can sequence 300 samples, which is still kind of a lot for metagenomics. So, but thankfully, if there's latitude, longitude coordinates for all of the soils, so we're going to do spatial joining the point-based layer with social determinants of health. And we sent these soils out to University of Minnesota so that we can do additional heavy metal analysis. So now we have all of the metals, and I'm excited to do analyses, but also terrified about what we're about to find. So, And so ultimately, these are some of the SDOH metrics that I'm thinking about working with. I'll probably have a few meetings with Marina later this semester to discuss this. And ultimately, I'm trying to kind of capture the major sources of these diversity of heavy metals. There's a lot of atmospheric deposition, so using environmental justice index and particulate matter concentrations is important. Vehicular exhaust is obviously a major source of metal deposition, so traffic intensity, walkability, transit availability. Plants are really important for soil, as Beth obviously discussed this morning, but also have plant roots can accumulate and sequester metals in soil. They can influence the microbiome by depositing carbon and influence actually the dynamics of microbiome adaptation in soil, and also the dynamics of the soil chemistry. So understanding the presence of plants in the urban landscape is really important for understanding what is happening within soil. And then we're going to look at probably also population, housing, number of households, and housing age. Older houses have more likely to have things like lead paint in them, so that's going to impact deposition of specific metals. Waste and waste effluent can be a metal source, so understanding populations, density and whatnot. And then the last one is industrial acres and percent industrial, because obviously these industrial sources, whether it's coal combustion or metal refineries and whatnot, are going to use massive sources of metal deposition, particularly of weird ones like cadmium and strontium and things like that. So that's really important to understand. And then the last one you can't see is historic redlining, because we talk about legacy effects in soil, because soil is able to adhere and kind of have a memory in some way. And so in agriculture, we talk about legacy effects with how does long-term corn impact soil, and so I'm using redlining because that's essentially a policy legacy effect that's then going to have these ripples for decades in how and when land is used throughout urban ecosystems. And so that's next steps. I thought I was going to be presenting data today, and I'm not, because the microbiome data analyses are a pain in the butt. Essentially, the microbiome data compresses around 2 terabytes of data, and I was just talking to Marina yesterday. I might have to reach out with the National Supercomputing Center and get more computational space, so it doesn't run for like 3 weeks on IGB's biocluster. There's a funny Reddit slide of people being angry about who's clogging the biocluster. So I'm not trying to be that person. So we just got those expanded heavy metal analyses last week. I'm going to do a lot of data wrangling, try to figure out how to get all the data spatial join in a way that's actually able to be analyzed. And then ultimately, this is my last year, my postdoc at the IGB, so I don't know how long I'll be around Illinois. So I would like the data to be available for environmental justice groups, urban planners, community groups, and so eventually we'll talk about integrating it with CHIVE and Chicago Health Atlas, because obviously metals have a very direct negative impact on human biology as well, and so I'm looking at more indirect effects and how that could potentially feed back onto humans, but ultimately I think the data could be used in a lot of more direct human health ways as well. So it's time for the acknowledgements. So I really want to thank all my collaborators. Dr. Angela Kent is my PhD advisor, and I came to her, I was like, I want to do this project, and she was just put me on the grant so you can get the money kind of thing. So shout out to her for being trusting my crazy ideas. Dr. Andrew Margant and his master's student George Watson were the ones who actually did the soil sampling. So there's no version of reality where this could be done without them. I am not a GIS personnel. I've never actually done geocomputational statistics before my postdoc. So Dr. Kolak and Healthy Regions Policy Lab are really important for providing resources and expertise with the analyses. Dr. Pamela Martinez, we were originally going to try to get human hospital data and patient record data to then see if there's a higher prevalence of antimicrobial resistance infection based on location. But the data, which we thought was supposed to be publicly available, was actually like $40,000. So we will not be doing that anytime soon. And then Dr. Noelle Noyes is at University of Minnesota in the veterinary research lab, and she's like an antibiotic resistant expert. And then you can't see the project support, but Alvaro Hernandez is the sequencing center, and he did all of the like actual sequencing of the soils. I just given the DNA extracts. He was very patient. And then Maisie Rathburn was our technician who helped me do the DNA extractions. Michael Somerville was Andrew's technician. Andrew is a brilliant soil chemist because he archives all of his soils. He air dries them and keeps them forever, essentially. And so Michael is the one who delivered the soils to lab and took them back. And so, and then Chris Fields is helping me with some of the bioinformatics, and he's actually a bioinformatician. So I'm funded through the Institute for Genomic Biology, and then the grant we got was through an ACES HATS grant called a FIRE grant, Future Interdisciplinary Research Exploration Grant. So, yeah. And thank you for listening. And if you have any questions, I'm happy to answer them.
Yes. Are you looking at like legacy-wise highway, the interstate highway system, but also where like shipping routes, supply chain, because diesel trucks? And
Yeah,
stuff.
you know, I actually haven't thought about that, but I think, and it's really just more in terms of like where to find that data. But I could definitely talk to Maria about that, whether or not she knows if that's easily accessible. Because you know, vehicular exhaust and diesel exhaust engines are going to be a huge, huge source of metal deposition in soils, and also sometimes things like rubber waste and whatnot. I just don't know. Again, I would just have to find that data and kind of figure out how to get it into the data set. But I think that's really smart. And we were just going to do like proximity roadways and traffic intensity just broadly. But if we can get higher resolution, like automotive activity and behavior, that would be a lot better.
I'm wondering if you can't get the routes, if you can get where truck stops are.
Yeah,
that's
that's a good idea.
like proxy kind of idea.
Yeah, 100%. That's a great idea. And there's U of I does have the engineering school is huge, and they do have a big automotive engineering. So I'm wondering if somebody up there might have that data.
Or some civil,
Or civil
engineers.
engineers.
Supply chain.
Yeah, that's a great idea. Yeah, I'll definitely try for sure. Yeah.
So, when we think about brownfield and superfund site remediation, like one of the more traditional routes of remediation is just trying to remove that contaminated layer of soil, which has the localized metal contamination. But I'm wondering if we know how the resistance is maybe spreading outside of that localized contamination, and so how effective traditional means of remediation are for addressing that.
Yeah. So I think a big factor about that will be also the movement of water through the brownfield site and the soil. And even if they're only taking the topsoil, whether or not any of the toxins from those leach into the lower layers of soil. And I think it would be cool to kind of do like a transect kind of base and soil sampling, out and around specific brownfield sites to see how that's disrupting the microbiome. And I guess if we found the spatial data for brownfield sites, I'm not sure how many there are actually in Chicago, or if they correspond to these sample sites, but that's additional analysis I think that could definitely be done with this data set. Microbiome data tends to be really large data. We'll easily get like thousands of columns, and so because again, each column will relate to there's two main different types of sequencing. If you do amplicon sequencing, each column is relating to a different species of microbe, so you can theoretically get 50,000 columns. And then with metagenomics, each column will be a different gene actually. And so the microbiome data itself is just really large data, and so that's why I'm like, I might get a supercomputer, because even without the metal data and out the SDOH data, doing spatial analyses with microbiome is going to be quite the endeavor. But again, I think that would be a really good local scale analysis of these metal resistant genes, because and just resistant genes as well, because again, there's antibiotic resistance that evolve from pesticides and other toxins as well. It's not just metals. And so understanding the movement and the mobility of the toxins and the waste from a brownfield site would be really important. And again, we do have high water or the high organic matter lets it hold to water really well. And so water movement is probably really important, especially if whether or not any of the toxins from brownfield site are moving outside of the bounds of the brownfield site. If that makes sense. But yeah, that's definitely again, if we get the spatial data and it corresponds to these points, I think that's a very specific hypothesis that could probably be answered with this data set when it's complete. Yeah.
Yeah. Awesome study. Really important. Thanks for sharing it with us today. A couple of questions. We talked about kind of the use of community clustering to kind of narrow down and different areas. And how well does that map on to like kind of community area?
Yeah, I have not gotten to that point yet because we definitely, I think some of the SDOH data are at the track level and some of them are community level, some of them are zip level, and so we're trying to figure out, especially things like redlining, which might be at like the zip level and not the census tract level. The big thing was just trying to be like, the big thing was like I could really just randomly sample the data set and randomly choose 300 samples, which was never really wrong to do. But because I wanted to make sure we got a good spread and coverage of where the samples were coming from Chicago, that's why we kind of did this like geospatially constrained k-means. And I chose, and this is gonna sound bad, but again, I needed it to be an relatively evenly sampling from across. And so that's why I did 30 clusters, because I was like, okay, we can afford 300 samples worth of sequencing, so doing 30 clusters allowed us to get to 300 samples, if that made sense. So we weren't really looking at the neighborhood boundaries when minimizing the sample size. It was trying to just be like, you know, and I think it was like $29,000 to do the sequencing on it. So it was really like, this is the maximum amount. And so it was like, I could randomly sample, but then there could be, cold spots in the data set because it didn't, And so that's why we did it that way. It wasn't around the neighborhood boundaries, but that was something that we thought about, and I was trying to decide if I should use census tract or zip code or something to constrain it even further, but I think I essentially used the chemistry analyses that Andrew had already done and did k-means based on the soil chemistry cluster, and that's what the clusters are based off of. So it's based off the soil chemistry, not the social determinants of the neighborhood boundaries, if that makes sense.
Yeah.
Yeah.
I think the social sciences I've been doing some work around public surveillance of poisoning, and the policy is really not very effective, and they focus primarily on healthy age.
Right.
But they're missing so much threat.
Yeah.
Half a million kids still suffer from poisoning.
Yeah.
I think there's, in the future,
Yeah. The camera box was blocking it, but the first paper that Andrew and George published from this data set was just the spatial variation in lead content in soil, in these same soils. So the lead data is already published and available in case you knew anybody who wanted to look specifically at lead. They did a second project looking at whether or not lead is accumulating in tomato fruit that people are growing in their backyard gardens. So, and that's one of the reasons why we want to make the data available, because at the end of the day, there's a lot of different, direct human health questions that could be asked of this data set.
I'll talk to the big problem, because I looked at this thing, but I don't have.
Yeah, the soil would be good. Yeah, it would be great, 100%. All right. Enjoy the rest of the day, everybody. I'll be here.
All right, now I'm going to introduce Christine Dannhausen-Brun with the Nordic Green Earth Foundation, giving her talk on leveraging the Miyawaki method of tree plantings to build SDOH communities.
Hi, everybody. I'm Christine Dannhausen-Brun. I'm happy to be here and talk to you less about data and more about improving social drivers of health. Do I do this to next?
Left click to start. Left click. One more time. No.
So a little about me. I am mom of 6 kids. They're the why of everything I do. They're 15 to 27, and I had the privilege of staying home with them for a long time. And I was trained in public health, worked at Johns Hopkins, worked at University of Chicago, had some really cool experiences, and thought I was going to be a working mom all the time. But I was fortunate enough to be able to stay home. And when the pandemic hit, I was like, I need to go back to work. Public health is in me, I need to go back to work. So I started working on mis and disinformation related to the pandemic. Through that work, I met a physician who who actually lived very near me, and she and I started talking about the social drivers of health and what we were seeing in the real world, and what we both had seen, her as a physician, me in public health, of the Band-Aid approaches to medicine. We identify someone that's having cardiovascular disease or diabetes, and we refer them to a lifestyle change program, and then we put them back in the same community where there's stressors, where there's no place to go out and get exercise, there's no place to get fresh fruit and vegetables, where there's metals in the soil. So we had lots of conversations about that, and one day she came to me and she said, do I think trees can improve health? And I emphatically answered yes, and that's how I started working with Nordson Green Earth Foundation and started doing some of this climate stuff that you see out here. Then, within a month of that, the University of Illinois College of Medicine came to me in Rockford and said, hey, we've got a 10-hour-a-week job, you want to do it? I'm like, okay, and so now I'm working, last week I worked 35 hours a week, but my goal is to be about 20 hours a week there. But I work on evaluation of CDC money to IDPH around cardiovascular disease, diabetes, and tobacco control. And these three big grants all focus on social drivers of health. So I am very fortunate to be able to tie wanting to heal the planet and also heal communities to sustain health. So Nordson Green Earth Foundation is what I'm speaking to you from today, and we work to increase tree equity around Chicagoland area. And people within Chicago, depending on where they live, may or may not have many trees. And they may have parkway trees, but they may not have access to a forest within a half mile or a park near them where they can go and just walk around. And proximity to those spaces affects your health. I'm going to try to cram a lot because I could talk for an hour and a half about this stuff. I trust you. And hearing Beth and hearing Sierra, all of it ties into the work that I do. Improving communities and increasing biodiversity. Sierra's work about looking at the microbiomes, that is what the Miyawaki forest is all about, is increasing the microbiomes in the soil. But also looking at the fact that this is an urban area. If you look out here, you see very little grass, very little plant material. Everything in here was built. So there was heavy equipment, heavy machinery on this, compacting the soil. And I loved your picture. I learned about this as we started to do the forest. Those are all little aggregates, those little circles in there. And when you compact the soil, all of those get crushed, decreasing the ability of the microbiomes to be there. I may have not quite right, but it's important. So these are the key objectives that I want to get across to you today. About Miyawaki Forest, tree equity, that it's a nature-based tool to build healthy communities, about the climate benefits of these forests for mitigating flooding, improving air quality and soil, and how these all can affect and improve social drivers of health, and how it all relates to each other, and all the benefits that you can get from these forests. And I will also want to point out, there are a lot of narratives in this work that need to be transformed. We say green spaces, and people say, oh, I've got a big lawn in front of my house, so that's a green space. That's not a green space that supports health. That's this much of something green that's not supporting any biodiversity, to what Beth talked about earlier today. So we need to get people to understand that having flowers all the time isn't what a native space is going to be. Having that native space die or be dormant and still be appreciating it for what it's doing, because it's supporting the biodiversity. It's decomposing and replenishing the soil and the microbiome. Chicago's tree canopy coverage. I speak about Chicago because this is where we work for Nordson Green Earth. It's far below the national average of 40%. Chicago is lacking across the city, but especially in its under-resourced neighborhoods where it can be 4 to 10% for its tree canopy. And American Forests, it's a leader in forest conservation. They've been around for 175 years. They say where the environment supports it, a canopy coverage of 40 to 60% is achievable. So there's a lot of work to be done, a lot of places where forests can be planted. And I want you to be able to walk away from today thinking about green spaces, but also thinking that you could plant a forest and you could plant it in an urban area. You can plant a tiny forest in a space as small as 2 parking spaces. American Forests also developed the tree equity score. Shoot, I haven't been advancing the slide, sorry. So this is Chicago's tree canopy coverage. We're at 23%. This is the tree equity score. And I want to point out that this is Markham, where we've done a lot of our greening work. They take a lot of factors into account, including there's a health burden index that looks at the disparities in health within a community. So there are systems and policies, and Sierra started to touch on it, and other speakers throughout the symposium have touched on it, that have driven low tree equity across Chicago, but also across the country. Homeowners Loan Corporation, which is the redlining. It was a US government sanctioned federal housing policy, and it existed from 1933 to 1968. I was born in 1969, so it is within our lifetimes. Racial covenants, which prevented Black people from owning land and then investing in the land. It was ruled unconstitutional in 1948. There are deeds across this country, tens of thousands of them, that still have that language in there saying that a Black person cannot own this land or cannot resell it. And then the federal highway system, which I brought up, divided communities specifically in white areas and colored or immigrant or Black or brown communities. And part of what it did so was to contain certain people and also to cut them off from being able to access the green spaces. So we created policies to limit even accessing those spaces that we know are healthy. So this is a map of redlining in Chicago from 1933. The green, for those who don't know, is the best places where investors say, yeah, let's give them money. Red, no, stay away from there. Or they would prioritize it for industrial or railroads, which added that burden of pollution to those communities. And if you look at Chicago's tree canopy coverage, the areas that are light yellow, light green, those tend to correspond to the areas that are redlined, and those light yellow and green are low tree equity areas. So the Miyawaki method. This is the method we use at Nordson Green Earth to try and plant a forest. We have only been able to plant one so far, but we're in discussions for several more. This forest is 3 years old. A little bit about the method. It was developed by Akira Miyawaki. He passed away in 2021, and the method focuses on natural vegetation, native species, healthy soil. So you excavate the area 3 feet deep, decompact it, put half of it back, amend the top half, and with natural stuff, not fertilizers, and then put it back in. And you add microbiomes where you need to create the natural process of what would be a native forest soil. So these are 2 pictures from up in Door County, Wisconsin, where I grew up. I grew up surrounded by blue and green spaces. I was very fortunate. But this is a roadway where you can see natural succession occurring, where the moss and lichen are breaking down the rocks, and that is the beginning process of a forest. So if we were all rock, the coral that you talked about earlier, that's what would happen first. Lichen and moss would start growing there, insects would come, they'd start dying, all of that would start creating the soil that we then grow things in. And so on the right you see a red cedar tree, which is a pioneer species for that area. And then it goes on to create a full natural forest with 4 layers, which would be your emergent canopy layer, your sub-canopy layer, a shrub layer, and a vine or perennial layer. Well, the Miyawaki forest tries to fast track nature and create in 20 years what it takes hundreds of years to create by nature itself. So you do that excavation, and then you plant all 4 layers of that final succession layers at once, and you leave everything within that forest. So this is another narrative that we change. When that dies there, we're going to cut it down and we're going to haul it away. Unless you're working with Pisa, I never know how to pronounce it, where they will come in and burn it. But we haul it away. And when you haul that away, you're taking away all the good stuff that comes from that biomass biodegrading. So you leave that in the soil. You don't prune. You let it fall off the trees. You let the leaves stay there. You let that leaf litter build up. So that is a really important piece of the Miyawaki forest. 5 minutes already. Okay. These are some of the results of a forest. It supports 16 times as many species as a non-native landscape. Matures in 20 years. After the first couple of years, there's no pruning. These are some of the benefits of why I see forests as infrastructure. They reduce heat island effects. They suck pollution out of the air. They reduce utility costs because of shade. They replenish our groundwater aquifers. And just spending 10 minutes in a forest can calm the central nervous system. I mean, even when you probably saw that first picture, some of you, that calmed you just a little bit. Although the speed of my talking right now. I'm trying to get so much in. And then these are all the ways that forests improve the social drivers of health. They encourage movement. So if you're a person with diabetes and you're doing this lifestyle change program and it's saying, just go out for a walk for 10 minutes after you eat. If you don't have a place to go for a walk, you're not going to do it. So putting a forest in a community that doesn't have green spaces where they can get out and walk and go in someplace cool, especially when it's 90 degrees out, matters. So forests are climate infrastructure. They capture carbon, flood mitigation that she already talked about, temperature mitigation, and they increase the biodiversity. They're health infrastructure, things I've already mentioned. They increase the movement. They get, especially there's been many studies of senior citizens where if there's a green space outside, they will get outside, they will move. Whereas if there isn't, they will stay in their apartment, stay seated, and it just doesn't, it affects their health. One of the things we hear from communities is it's going to increase crime, but the communities that have more green space have less crime because people are drawn out of their houses. And when they're drawn out of their houses, they're keeping an eye on the neighborhood. They're watching the kids. They're seeing what's going on. So you're building stronger neighborhoods and you're getting people to connect with each other, which reduces isolation and loneliness. So this is some of the Nordson Green Earth projects that we've done. Our forest, we planted a nature nook, then we did a prairie path, and we do lots of community tabling events. And the reason we got the first spot for the forest, we kept talking with the community and we wanted to do more. They were not ready to add another forest, but we said, okay, let's talk about what else can we do then. So that is how we've gotten to some of these other things. So this is where our first forest is. It's 6th District Courthouse, Circuit Court of Cook County. Most of these trees here have since been removed because they all died. They were, there's plenty of issues, that's a whole nother talk of how we do tree planting in the US. So this was our planting day 3 years ago. We had 75 people come out with us. This is how small the plants are when we plant them. They're tiny. A toddler can help plant this. And this is at 4 months later. Look how much it's grown because the soil is so well prepped for the plants. They soak it up. So this is September 2024. I have not gone out with the drone yet to do a September 2025 photo, but the plants are all taller than me at this point. Like 3 years, they are more than taller than me. This is some of the biodiversity in there. There's chokeberries. I was out there several weeks ago, and as I approached the forest, like 50 birds flew out of one of the elderberry bushes. And this would otherwise be lawn with no birds on it. And so as we all walked up, we were just like, that was so cool. 1 minute. One tree planting came to us with money to plant another forest. We said we don't have a space for a forest, so we said we would talk with the library. They wanted a green space. So what we created on this 6,000 square feet of lawn is a 300-foot walking path, and it's a 3-phase planting. So we planted the trees and shrubs in April. That's what you see here. And this photo is Tristan Shaw at Possibility Place Nursery, who you should talk to, all native. That's his emotional support tree. And if you go to One Tree Planted site, YouTube site, you'll see a video about that. This is phase 2 planting, where we planted a bunch of perennials on the east side. And then in November, we will seed the rest of the lawn that you see here, but we put in a story walk to engage residents to come out and use this green space. And then there's one of the signs will have information on going into the library to find out more ways to engage with it, because we're trying to create a birding project to see how that increases biodiversity. And I will end with, it's great to plant a forest, but it's even more important right now to save all the old growth forests that we have. So write letters, talk to your congressman, and make sure that we do not log what exists already. And that's my last slide. Questions?
Yeah, I have a question, whether you've connected with the city of Chicago at all in terms of this mental figure.
So we are on the Chicago Tree Equity Working Group, and because of my work at U of I have not been able to make many of the meetings, but we were on that, we presented to them. They are definitely aware of it, and we are working with, I'm also part of Climate Reality, and I'm working with some women there, talking with U of I for the Chicago campus to possibly put one in there. And that's in the very beginning stages of meetings. But the hardest part around planting these forests is the community engagement of transforming that narrative that a forest is a good thing. When I went through the Suki Forest Maker Fellowship, one of the things we talked about is we need to change the narrative from landscaping to forestscaping, and how do you put in a forest with a gathering space within it, or a native playground attached to it, or benches where people can they can go to the forest, and they can just sit for 10 minutes and just take it all in, because we know that it's good for your health, period.
Hi, thank you so much. This was really interesting. I'm going to talk a bit more about tree equity later today, so I love this. I'm just curious if you could talk a little bit more about the logistics of, which you kind of touched on it, but like actually making this forest in different places in terms of like the financial costs, like how many people are involved, like maintaining, and all the things, yeah.
So the biggest cost for planting it is the equipment that you need to do the excavation. We're part of an international research group that's looking at the Miyawaki method, and the true methodology says excavate 3 feet, but we know around the world that not everybody is doing that because there's cost limitations, or in Chicago, we bury lots of our utilities. So one of the issues of that, where that path is we had talked about, oh, this would be a perfect place for a forest, and then you can have people walk through. There's a huge gas main underneath there. And I'm like, okay, I'm not bringing an excavator in here and digging, even if I know it's 5 feet deep, and I'm only excavating 3 feet, because if something happens later, then you lose parts of the forest. So that, we thought about the empty lots, because there's 40,000 empty lots in Chicago. But you have to live in the community, and I fully support that. To be able to maintain the space, you have to be the community, you have to want it. And so one of the things that when we go talk about is, if you have a bunch of empty lots in your community, or you have a bunch of green space, or you have a parking lot that's sitting there next to an abandoned strip mall, those are spaces that can be considered for a forest. But the community, in addition to getting the community buy-in, there also has to be a changing of the narrative around this country that is a value add to the community. We tend to think of development as what building is going to go there, what business is going to go there, because that will pay taxes and that will bring people to a community. But if you're in a community that has been neglected for 50, 60, 70 years, helping to improve the aesthetics of the community is another piece of the development. And everybody, when you look at where the highest real estate, Winnetka, Wilmette, what's there? Trees. Every tree or street is shaded. There's a park within 10 minutes of everybody's house. So understanding that what you want is nature. When I do community assessments too, community needs assessments, and you go and ask people what they need for their health, and they say, I need a physician nearby, which they do, but no one ever says, I need a forest. I need nature to be within 5 minutes, because they don't understand the impact of that on their health. So having physicians talking about, do you get outside? When you do get outside, how long are you out there? What are you doing? Are you just getting outside because you're going to and from work? Are you getting outside because you're spending a bit of time out there to just calm yourself down and just be? So those are a lot of the narratives that we have to continue to transform. That answers it.
Yeah, thank you.
Question.
Oh, yeah. Love all the soil. love that. Have you thought to kind of add on to that? Have you thought about kind of making so especially with the path, have you thought about doing like a plant ID walk where like people can follow the map to kind of see one of the parks by my house in Urbana has like a tree walk, and they have the map of like, here's all the trees and you take this path. Just to make sure people are not only going out but actually integrating the garden or the forest into their activity.
So there's something called arb.net that creates kind of those identifying, and because I'm working 2 jobs, and it's 4 moms who started Nordson-Brun Foundation about 4 years ago, which to this day I'm still amazed that we are still going as this nonprofit where none of us are getting paid, but we're just devoted to it. And so we need to build out our spokes to be able to do that, but that's definitely something that's in our wheelhouse of what we want to do. I want to say we've planted 1,700 plants, so that one side of the garden walk or parade path has 900 plants on it. So identifying all of that take a little bit of time, but even just identifying the trees and shrubs would be really useful. We've worked with over 160 volunteers, just for numbers to show. Other questions? Thank you, everybody.
All right, so that concludes session A. We are now entering lunch, so you can get a last bit of coffee or hot tea and make your way back to the main session. Okay, thank everyone.